In the past, I've created data pipelines that have been scheduled to run at all times of the day. In a lot of occasions, these data pipelines need to run outside of hours, either because they're taking data from a critical business system and you don't want to impact the end users of that system, or because you want to snapshot the data from that system at the end of the day. I've even been the unlucky one who has to stay up late to monitor jobs, or get up early to ensure that all of jobs have processed and the data is ready for the start of the day. There are a number of different reasons why a job or data pipeline may fail overnight. Some of the more common reasons are network interruption, so connecting between your data warehouse or your target and your source. It can be data quality or data design, where all of a sudden a different type of data turns up to the expected data type. And other infrastructure related problems, such as processing and conflicting job, that can slow the whole job down and stop the job from processing, if not completely stop it with something like a table lock or a row lock. Our job as data engineers is to think about the overall design of our pipeline and mitigate as many risks in that design as possible. So this could include data quality checks, looking at the data as it comes in, making sure it's going to fit before we push it down the pipeline, data restriction techniques where we only pass through good data and we flag out error data and flag that back to whoever owns that data, and things like system monitoring, so overall architecture, making sure that everything's working and checking to make sure it's as performant as possible. Recently, one of our clients came to us with a problem. They had a connectivity issue, pulling data out from one of their source systems and landing it in their data warehouse. And they found that the connectivity was severed from the network, meaning the job would fail halfway through pulling the data across. We came up with an auto restart job within WhereScape RED, which would connect to the failed job and restart the job. So let's head over to the desktop now and I can take you through the steps to build this. So here we have a simple WhereScape RED repository. There's a few tables, there's a few stages, there's nothing very exciting in here, but we have a job, and you can see we have a load job, and we have in the scheduler, job will run every 15 minutes. Now, there could be lots of reasons why this job might fail. There could be a network connectivity issue, there could be a data quality issue, there could be a number of different things that will stop this job working. So if you run this job at 3 o'clock in the morning, you know that there could be network issues during that time. Then the last thing you want is for the job just to fail and sit there and wait for a human being to come back. How do we get around that? Well, luckily, inside of WhereScape RED, the metadata held in the repository regarding this job can be used, and it can be used in a way to help us restart the job. Let's show you how. Now, this data warehouse is using a SQL server to hold all the metadata. In this SQL server, you'll be able to find the WS tables which contain all of the metadata. And the one we're really looking for is the WS work job run. This holds all of the information about jobs that are currently running, and then we have no jobs running. So if I jump back to my repository, start my job, I go back to my repository and start queuing. As soon as the scheduler has started the job, it will appear here, like so. There we go, and we can see the job is now running. So in this metadata repository, you get to see the status, but the thing I'm really interested in is the restart. So as the job is running, you can see there's a 0 restart. Now the job is paired off with tasks. The tasks are the things that can go wrong. So there is the job work tasks run table, which will hold all of the tasks that are running for this particular job. But I'm not looking at the individual tasks, I'm looking at the individual job. So as soon as that job's completed, when you refresh, the run table will be cleared out. And if we go back to WhereScape RED, we can now see the task is now run and it's completed and it ran today. Brilliant. So we know everything's working the way it should. So going back to the metadata, what I'd like to do is poll this table and check to see if any job has failed. So let's force a job to fail to see what it looks like. So now the job is started. If I now halt the job, artificially stop the job from running. So now we've artificially held the job, and all we've done is halted the job from processing. If we then go back to our repository, you can see you have a status of fail because the job has been artificially held. So what we'd like to do is query that. So I can now put in status equals F. And now that's going to give me all of my jobs that are in a failed mode. So if this job has failed for a legitimate reason, say the network has severed the connection between the source system and the load table, so we can no longer load the data in, the task will fail. The task, as that fails, will update the job. The job will then be set to a failed status, and I'd be able to see this. So in this occasion, I may want to restart the job. So there is the restart column here, and I probably, if I'm designing this to restart overnight, I probably don't want it to endlessly restart until it completes, because that could create a perpetual loop. So I'm just going to put in here anything where the restart is less than 10 to begin with. So now I have a list of all of my jobs that are in a failed status that have been restarted less than 10 times, and I can see what's happened, and I can run through these jobs. So it gives me the ability to detect what's happening using the metadata, and now I can build a script or a custom procedure to detect this and then start to restart the job. In that case, what we're going to do is use another of the standard procedures within the metadata, and that is called WSJob restart. And in here, all we have to do is provide the sequence number, the job name, and then we can then fire that off as a procedure. So we can use the information held in this metadata table to call the stored procedure to restart the job that's failed. As that happens, the stored procedure will automatically increment up the restart count. We can use several ways of doing this, but just to keep things simple and to illustrate the what ifs, I'm going to build a simple cursor, and the cursor will then be used to loop through all of the jobs and then fire off. What we'd need to do here is declare job cursor. So now we need to select, and let's just grab that query we've already written. So we're going to take the key of the job, we're going to take the name of the job, we also want the sequence number because that's needed. That's it, that's as much as we want. So let's remove all of the other columns out. Here we have it, we have the select table, we can run this select query, we highlight it, you can see my load job sat there. And actually we will probably need to take the job name through it again because we want to tell the stored procedure the name of the job we want to restart. So now once we've selected that query, the cursor's being created for that query. We want to open the job cursor and we want to fetch next from job cursor. Okay, and we put it into some variables because this will help us just understand it's coming from. Start job ID, so that's the ID of the job that's failed. P restart job name and P restart the job. Let's get the sequence number as well because we need that for the restart procedure. P underscore restart job. All of these parameters have been baked in. What I will do is go back and quickly add in these variables. There we've set them, and what you'll need to do is set all of these to meet the value within the stored procedure. Match up, otherwise we could be adding in different value types or different amounts. We also need to collect the return values, so I'm going to create another set of variables just for the return values, and this would be the return values that come out of the procedure. Going back into the cursor, we've built the cursor, we've collected all the data from the jobs, we've opened the cursor, we fetched the first record in, and now we want to do something with this. So we're going to use a while at fetch status is equal to 0, meaning we have something. We begin, we're going to do the restart the job. So you can write this query however you want, but I'm just going to use exec at return value equals. Now my metadata is in the DBO schema, and I want to find the job restart. Just to make this a little bit easier to read, first thing I want to put in is the P underscore restart, and then we want the job name, and then we want to write the next thing is the task we want to restart. But if we set it as null, it will just pick up the next task in the job. Restarted job ID. The next thing in there will be task ID, which again, we just want it to pick up the next task, not necessarily a specific task ID. And after that, we want to give it the restart job name, restart job. And then after that, we're going to start getting some return values. So we've already put all of the return values from that stored procedure into the return underscore value, but we want to get the return code, and that will equal at p underscore return code output, and then we would want to get the message as well at p underscore return underscore message equals an output, and finally at p underscore result equals at p underscore result output. Store procedure now will execute and return all of the outcome into the return value, but the idea here is that we execute this store procedure, it will take the job that we've just collected from the cursor and then restart that job using the WhereScape standard stored procedure that would normally be triggered off by the UI, but in this case we're triggering it off from this custom procedure. The next thing we'd need to do is look at the message. We'll start to build the message up so we can return that message back into the metadata, because this custom procedure, we really want to build that into our metadata repository so that it can work and be called by a job. So the first thing I'm going to do is just put a little note to say builds the return message, and then I'm going to set my at p job return message equals at p job return message plus, put in a little bracket to do the code, my string value, return code, close it with a little bracket as well. Actually, I'm going to then put a new line in and then put in plus at p return message. So that will take the current value, add in the code. Okay, cool. So we want to set the number of rows that have been set off. I'm going to put in, this is a variable that you'll find inside of the WhereScape template procedure. So the v-row count equals the v-row count plus 1. And what this will be used to do is it will be set to 0 when we start our cursor, and then for every job it will add 1, and then at the end of our custom procedure the metadata will be updated to show how many jobs were restarted when this procedure ran. Now I've done all of that, I'm just going to comment this out. We need to fetch, I can grab that, pop that in, so that's going to grab the next record. And then after we've done that, we would close our cursor and then we would deallocate. So there we go, we've finished our cursor, and this will now open jobs that have failed, that have been restarted less than 10 times, and it will restart them all. So why don't we give it a little try? If we go back to our repository, you can see that we still have our job failed, where we artificially halted the job to create that failed status. We go back to our procedure and I run this now. The procedures come back and it's completed. If I go back to my red repository and restart, you can see the job has been restarted. Now it's running and now it's completed. So you can see that that's all happened. The cursor's worked. Now we need to incorporate it within a procedure within WhereScape so that we can have a job running, a custom procedure picking up any failed jobs and restarting them. We're going to, first of all, we're going to create a custom procedure. So I'm going to expand procedures, click on new, and then I'm going to call this custom underscore restart job. So in here I have a completely blank script, but I'm going to use one I prepared earlier. So I'll paste this in. We have procedures going to be created. It's going to be called custom restart job, and it's going to have all the standard variables used and have all the standard parameters used. It's got all of the variables that you normally get as part of the template for a procedure, an update procedure. And in here we have the start of our job. So this is the variables that get created for the job, and that's going to be used in the cursor. We all have all the return values. Again, these are used in the cursor. We have declared the cursor. We have the select statement that's going to pick everything back. At the moment we're using 10 as a restart value. We're going to open the job, open the cursor, and then it's going to loop through each of the jobs that are in a failed status. It's going to fire them all off and then let the scheduler pick up those jobs. And once it's done, it's going to complete. And the bottom part of this procedure does the standard process of collecting all of the data built up through the custom procedure and stamping that back into the metadata repository. So now if we save this and compile it, we now have this as a custom procedure within our repository. Now, in order to get this job to work, I would need this custom procedure to be executed on a scheduled basis to pick up all of the failed jobs and restart it. So if I hop over to my scheduler and I create a new job, restart failed jobs, any failed jobs. And what I would tend to do is run this either for the entire day or run it during my batch window when I need something to automatically pick up failures. For this, I'm going to use the current time. So I'm going to use custom, and I'm going to say I want this to run every 10 minutes between 9 AM and 12. Okay, so this will run for 3 hours between 9 and 12, Monday to Sunday. I'm not going to put any parent jobs because I want this to run independently. Of course, I can come in and put some success and failure commands in, but I won't for the time being. And all I'm going to do is add in my custom restart, have a new job in my repository that is waiting for the jobs to fail. So if I start this job, I've started my load job, and I'm going to wait for the scheduler to pick it up and execute. Now I can halt the job to create a false failure. Okay, so now we've created a false failure by halting the job. And now if I run my restart jobs, once that's executed, it will restart this failed job. Let's restart. Okay, so the job's now running. Brilliant. And now you can see that my load job 43 has restarted and completed. So I didn't do anything to that job. I just started my restart. So now I have my custom procedure controlling on restarting my jobs for me. And in the situation where I may have a network failure and I might need to restart the job, this can help me save some time. And rather than waiting until a human comes in the morning to restart the jobs, I'm going to be waiting as long as 10 minutes or however long I set the frequency for this job to be. So every 10 minutes, it could be every 5 minutes. I'll leave it to you to dictate how you want it to work. Now, the other consideration we can play with inside of this custom restart is how many times do we want the job to restart. So if I go into my custom procedure, you can see that at the moment I am using 10 as a hard-coded value to control how many times the job's restarted. So let's just pop over to the metadata and see what that looks like, what the jobs look like when they have completed. Okay, so in the metadata, all of the jobs that have run, so this is in a slightly different table. This is in the _log table, which has all of the history. And in here, it's the same structure, but in this case, all the jobs have completed or been aborted. Well, the last job we had got the restart job to pick up and restart for us was sequence 43, and you can see here that the count for restart has been added up to 1. So again, that's all controlled by the WhereScape stored procedure, so we're allowing that to continue to do what it needs to do. That's what we are looking to control with a variable. Hopping back to my WhereScape repository, first of all I need to create a parameter. So I'm going to go into my parameters and I'm going to call this restart limit, and I'm going to give it a value of 10. So there we have our restart limit. We've set it to 10. Of course, each environment can have different values. So you might want to have more restarts or less restarts in your production environment. You may want to have less or more in development. It's completely up to you how you can control that. But now we need to add this value into our custom procedure. So let's jump over and see how we can do that. So the first thing we need to do is create a variable. So I'm going to create a new here at v_restart_limit. So there you go, we have our variable. Now we want to set the variable. So there's a couple of different ways we can do this. I'm going to show you the easy way. In the stored procedures within WhereScape, there is a WS read parameter. And in here, all we need to give to this is the parameter name, and then we get the output of the value and the comment. Let's incorporate that within our script. Okay, so now we're back in our repository, and straight away I've done something wrong. What we want to do is set our variable into the restart limit. what we'll need to do first is execute the WS parameter read. We want to give it the name of our parameter that we want to read from. So I've called this restart limit. And then we want to get the output. Now we haven't created a variable for this yet. So if I just do p underscore value equals p underscore value output, and what I'll do quickly is I'll just run up here. The value that's returned from the stored procedure WS parameter p value is a varchar 2000, so we'll set that as a varchar 2000 to begin with. So going back down to this line, that p value will return a string, so we want to convert that. So just do a cast that as integer. So again, you can increase this to whatever you'd like. So now we've set the p value into the restart. Let's add this into the select query. So we scroll down, and in this bit here we will put in restart. So now the parameter value is being fed all the way through into the select query. So whatever we put into the restart limit parameter will then be used in our select query. So let's call that. Made a version of it. So if we go back to our restart limit and we set the restart of 1, click on OK, and wait for the scheduler to pick up this job. Right, now I'm going to halt the job, artificially fail the job. There we go. So it's done 1. And now I'm going to wait for the restart fail jobs to start. So it will complete this task and then it will halt. There we go. The job is now halted again, and if I bring back in my query, you can see that we've already restarted once. And going back into WhereScape, my parameter is set to 1. So now when my restart job starts again, it will leave this job alone. So that was our auto restart job. Hopefully you found that useful and it's given you some ideas of how you could implement it for your company. Thank you very much for watching this. I hope you found it informative. Don't forget to like and subscribe. See you next time.